The mathematical concept that we have chosen to focus on is probability, better known as chance. In this short presentation, we will be looking at what probability is and the common misconceptions that students may have to give you, our fellow teachers, the confidence to teach probability in the classroom. Probability is the likelihood of an event to occur that can be ordered on a scale from 0 to 1. 0 being impossible and 1 being certain.
One problem that can arise from teaching and learning probability is the varying methods of considering data when conducting chance experiments. As outlined by Batanero and Chernoff 2018, just because students are engaged in experimentation does not guarantee meaningful learning will occur. Experimentation involves many knowledge aspects that can distract students, so hindering students in favouring probabilistic reasoning over deterministic reasoning. Deterministic reasoning is the analysis of data that is known to be true, or what actually occurs in experiments. For example, if a student was to conduct an experiment with a spinner and record what colours it lands on 20 times, if the student got results like this, they might believe that it is impossible for the spinner to land on yellow if they were to use deterministic reasoning. In this case, they might conclude that the chance of getting a red is 45%, getting a green is 30%, blue is 25%, and yellow is 0%. However, probabilistic reasoning includes consideration of all possible outcomes of an event, or what might not have occurred in their experiment but still could have happened. If students were using probabilistic reasoning, they could conclude that the chance of getting each colour is 25%, but then compare this to their actual results. Students should be encouraged to use probabilistic reasoning during their experiments so that they can accurately assign probabilities as values between 0 and 1 to describe their outcomes. Furthermore, students require this understanding so that they do not accept the findings of their experiments as the absolute truth and are still able to consider all possible outcomes of an event.
When considering possible outcomes, students often have difficulty listing all the possible outcomes of an event. As children are immersed in a way of talking about probability that is much more about event prediction, there is often confusion over all the possible outcomes of an experiment. Let's take a look at a two-sided coin as an example. When listing the possible outcomes, if the coin was flipped 3 times, students may not be able to identify all the possible outcomes of this event. Using a tree diagram is a useful visual way for the students to ensure that all outcomes are listed. After completing the diagram, students can list all outcomes to get a complete list of possibilities.